Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. So today I plan to discuss with you all about the applications of factors that affect the rate of reactions in daily life. So hari ini saya merancang untuk berbincang dengan kamu semua berkaitan dengan faktor-faktor yang mempengaruhi kadar tindak balas dalam kehidupan seharian kita, aplikasinya dalam kehidupan seharian kita. So, we'll go for the first one, the size factor. The size factor. So, for the first example, I give the applications in medicine. For the size factor, applications in medicine. Alright. For example here, we have antacid tablet. So antacid tablet we use to treat gastric, right? For your information, antacid tablet we use to treat gastric, alright. Usually, doctor will ask their patients to chew the tablet instead of swallowing. Why? This is because when the patient chew the tablet, it will breaking the tablet into smaller pieces that will increase the total surface area of the medicine and then will increase the rate of reactions between medicine and acid in the stomach and then will increase the effectiveness of the medicine to treat the gastric. So, dekat sini untuk factor of size, untuk factor size, saya akan bagi contoh aplikasi dalam perubatan. Alright. So dekat sini kita ada antacid tablet. So untuk pengetahuan kamu, antacid tablet ini digunakan untuk menyembuhkan penyakit gastrik. Alright. Okay, selalunya doktor akan menasihati pesakitnya untuk mengunyah antacid tablet tadi itu daripada menelannya. Kenapa? Okay, apabila pesakit itu mengunyah antacid tablet itu, dia akan breaking down, dia akan pecahkan ubat itu dalam bentuk kecil-kecil. So maknanya bila ubat tu dalam bentuk kecil-kecil, dia total surface area dia tinggi. So dia akan tinggikan kadar tindak balas antara ubat tadi itu dengan asid yang ada dalam perut. So, dia akan meningkatkan lagi keberkesanan ubat itu untuk menyembuhkan penyakit gastrik tadi. Alright. Next, we will go for the second example. So, I give applications in cooking. Alright. For example here, if we have potatoes, uncut potatoes and the sliced potato, the potato that we cut into slice. So which one will give high rate of reactions? Which one will cook first? Of course, the sliced potato will have high rate of reaction and will cook first. This is because potatoes that we cut into slice will have high total surface area exposed to the cooking oil compared to uncut potato. So that's why the sliced potato that we cut into slice will cook faster. Alright. So, contoh yang kedua saya bagi aplikasi dalam bentuk masakan. Okay, contohnya kat sini kita ada potatoes. Uncut potatoes dengan potato yang kita cutkan dia dalam bentuk slice. Alright, dalam bentuk slice. Into thin slice. So, dekat sini, apabila kita masak potatoes ni, yang mana akan lagi cepat masak? Okay, so semestinya potato yang kita potongkan dia dalam bentuk slice itu akan masak terlebih dahulu kerana dia punya surface area exposed to cooking oil. Dia punya surface area dia, permukaan dia, luas permukaan dia yang terdedah kepada minyak masak itu lebih tinggi dan akan menyebabkan kadar tindak balasnya lebih tinggi dan menyebabkan the tin potato yang kita potong dalam slice itu akan lebih cepat masak berbanding dengan uncut potato yang kita tak cut tu. Contohnya kita masak dia dalam bentuk seketul besar tu, of course lah dia akan lambat masak berbanding dengan potatoes yang kita cut into slice. Alright, so next we will go for the second one, concentration factor. So the application that I will give to you is the corrosions due to acid rain. Alright, so for your information, building that made of iron located near industrial area corrode faster due to acid rain. Why? Because at the industrial area, concentrations of the acidic pollutants such as sulfur dioxide is high. So high concentration of acidic pollutant will increase the level of acid rain and the rate of reactions increase. That's why the iron located near the industrial area will corrode faster due to high concentration of the acid rain compared to the another area lah. Alright, so kat sini faktor yang kedua, concentration. Alright, so aplikasi yang saya bagi contoh ni, contoh dia pengkaratan besi, pengkaratan iron disebabkan hujan acid rain. Alright, untuk pengetahuan kamu, bangunan-bangunan yang diperbuat daripada iron yang berada dekat dengan kawasan industri akan cepat karat disebabkan acid rain, disebabkan hujan asid. Ini adalah kerana dekat kawasan industri dia punya concentration of sulfur dioxide that release high concentration of acidic pollutant. Maknanya sulfur dioxide ni adalah acidic pollutant yang menyebabkan the acid rain itu menjadi high concentration that will cause the iron around the area of the industrial will corrode faster due to the high concentration of the acidic rain. Because of the high concentration acidic rain just now, it will cause high rate of reaction that will cause the ions to corrode faster. Alright, so next we go for the second one, temperature factor. So the application that I will give to you is cleaning. Alright, so example here, washing clothes using detergents and hot water, the process of washing will be even quicker. So maknanya dekat sini faktor yang seterusnya adalah suhu. So aplikasi suhu yang saya bagi contoh kat sini adalah apabila kita basuh pakaian lah, right? Apabila kita basuh pakaian guna sabun dengan air panas akan lebih cepat dia bersih berbanding jika kita basuh baju dengan air sejuk. So dia akan kurang bersih dekat situ lah, ataupun lambat bersih di situ. So basuh baju dengan air panas dengan sabun lebih cepat kerana high rate of reaction ada berlaku di situ. So menyebabkan proses pembasuhan itu lebih cepat. And then we go for the second example, cooking food. Alright, cooking food. Food also cook faster at high temperature. Alright, contohnya kat sini saya bagi masa kita goreng ikan lah, right? Contohnya kita goreng ikan. Contohnya satu ikan ni kita goreng dekat suhunya katakanlah 70 degree Celsius. Dan satu lagi ikan ni kita goreng dia dekat suhu 100 degree Celsius. So yang mana akan lebih cepat masak? Of course lah, ikan yang kita goreng dekat 100 degree Celsius itu akan lebih cepat masak berbanding dengan ikan yang kita goreng dekat 70 degree Celsius. So at the higher temperature, higher rate of reaction. So reactions between ikan yang kita goreng tadi dengan minyak tu lebih tinggi. Alright. So next kita pergi kepada, next we'll go for the catalyst factor. Alright, so the applications in our daily life, I give making of alcohol, pembuatan alkohol. And for your information, ethanol is the main ingredient in alcoholic drink. Alright, ethanol produced through the fermentations of glucose with the help of enzyme in yeast as a catalyst at 37 degrees Celsius. So what is mean by fermentation? Fermentation is the chemical breakdown of substance by bacteria, yeast or other microorganism. Okay, so faktor yang seterusnya adalah faktor catalyst. So, contoh aplikasi ini adalah production, penghasilan alkohol. Production of alcohol. Okay, untuk pengetahuan kamu, ethanol adalah sejenis alkohol dan dia merupakan adalah bahan utama dalam minuman beralkohol ini. So ethanol ni dia dihasilkan through fermentations of glucose. Maknanya chemical breakdown of glucose by with the help of enzyme in the yeast as catalyst at 37 degrees Celsius. Maknanya ethanol ni dihasilkan through fermentation of glucose dengan pertolongan enzim yang ada dalam yeast as a catalyst at 37 degrees Celsius. So maknanya proses penghasilan, proses fermentation of glucose tu akan lebih cepat dengan adanya pertolongan daripada enzim in yeast as a catalyst. Okay, so that's the applications, aplikasi faktor-faktor kadar tindak balas dalam kehidupan seharian kita. So itulah beberapa contoh yang adalah. Alright. Okay, so next kita akan pergi kepada, saya akan ulang balik, kita akan buat revision balik. We will do revisions on rate of reactions. The first subtopic, which is 7.1, determining of rate of reaction. Determining rate of reaction. So first, the definitions of rate of reaction. Alright, rate of reactions is the change in the quantity of reactants per unit time, or the change in the quantity of product per unit time. Alright, I repeat again, the definitions of rate of reaction. Rate of reaction is the change in the quantity of reactant per unit time, or the change in the quantity of product per unit time. Alright, so unit for rate of reaction. So we have a few unit of rate of reactions. So if the rate of reaction is related to the mass, so the unit should be gram per second or gram per minute. So the minute you should write in words. The minute should write in word. Alright. So if the rate of reactions is related to the volume, so the unit should be cm cube per second or or cm cube per minute. Cm cube per minute. So minute you should write in word. I repeat again, minute should write in word. Alright. So if the rate of reaction is related to the concentration, if the rate of reaction is related to the concentration. So the unit should be mole dm cube per dm cube, mole per dm cube per second, or mole per dm cube per minute. So I repeat again, minute should be right in words. This is a new syllabus, so minute should write in words. Alright, so for your informations, there are two types of reactions. So we have slow reactions and we have fast reaction. Alright, so slow reactions, the time taken for the reaction is long and the rate of reaction at low rate. I repeat again, slow reaction, the time taken for the reaction is long and the rate of reaction at low rate. Alright, so for fast reaction, the time taken for the reaction is short and the rate of reaction is high. I repeat again, for the fast reaction, time taken for the reaction is short and the rate of reaction is at high rate. Alright, so next we'll go for example of slow reaction. So there are a few examples of slow reaction. We have food decay, photosynthesis, rock erosions, and corrosions of metal. So maknanya slow reaction. Slow reaction, reaction yang perlahan seperti food decay, photosynthesis, hakisan batu dan pengkaratan. Alright, next we have fast reaction. Fast reaction, we have fireworks, we have combustion of gas and ignition of match. Alright, maknanya fast reaction ni reaction yang berlaku dengan cepat lah, seperti bunga api. So macam mana yang kita hidupkan apa tu mancis, and then combustions of gas lah, pembakaran gas. Alright, that is a fast reaction. Alright, next we go for the rate of reactions. Rate of reactions are divided into two types. We have average rate of reactions and we have instantaneous rate of reaction. Alright, average rate of reaction is the average value for the rate of reaction that occur in particular time interval. I repeat again, average rate of reaction is the average value for the rate of reaction that occur in particular time interval, where instantaneous rate of reaction is a rate of reaction at particular point of time or rate of reaction at a given time. That is instantaneous rate of reaction. Alright, so now we go for the calculation. Alright, calculation. Okay, how to calculate the overall average rate of reaction? How to calculate the overall average rate of reaction? So for example, so if we have a graph here, right, we have a graph here. So let's say this one is a volume of gas, volume of gas, cm cube, right? And then we have time here, time we have in second. So the range is 0. Let's say it's a 30, here is 60, here is 90, this is 120, and here is 150, and here is 180. And we have here 10, 20, 30, 40, 50, and 60. Alright. So let's say we have a graph here. Alright. So now we already have a graph. So if the question asks, calculate the overall average rate of reaction. Overall average rate of reaction is mean to calculate the overall average rate of reactions means you need to calculate the overall rate of reaction starting from the zero until the reaction is complete. So here is the reaction completes, where the reactions stop. Reaction stop. Alright. So I repeat again, overall average rate of reaction, you need to calculate the average rate of reaction from the zero until where the reaction stop. Reaction stop where is the volume of gas is constant. So the point where the volume of gas is constant, that is where the reaction stop. So I repeat again, overall average rate of reaction is you need to calculate the rate of reaction from zero until where the reaction stop. So we have here, and we have a volume here. Alright, I repeat again, overall average rate of reaction, you need to calculate the rate of reactions. And overall average rate of reaction, you need to calculate the rate of reaction from zero until where the reaction stop, where the point where the reaction stop. Alright, so you need to calculate the rate of reaction at this area. Alright, overall average rate of reaction, we use formula V over T, where V is the total volume of gas collected. V is the total volume of gas collected, where T is the time taken. Alright, so the volume where the reaction stop here, maybe around maybe 45, right? So the volume is 45, and the time taken is maybe around 160, maybe 160 over 160. So the overall average rate of reaction is 45 divided by 160. Alright, so it's a 0.28. So 0.28. So the formula, the unit is cm cube per second. Alright, 0.28 cm cube per second. 0.28 cm cube per second. Alright, this is the first one, how to calculate the overall average rate of reaction. I repeat again, how to calculate the overall average rate of reaction. So overall average rate of reaction is mean we need to calculate the rate of reaction from zero until the reaction stop. Alright, the reaction stop where the volume of gas constant. The first point where the volume of gas starts to constant, that is where the reaction stop. Alright, for the next one, Alright, for the next one, so how to calculate the average rate of reaction for the first minute? Alright, so I will draw the graph first. Right, if the question said calculate the average rate of reaction at the first minute. So first minute, the key point is the first minute. So first minute, minit yang pertama. Maknanya minit yang pertama. Minit yang pertama adalah minit yang satu minit, 60 second. The first minute, minit ke 1, 60 second. So it means it wants the first minute. This one, the average rate of reaction at the first minute, means from 0 to 60 second. Daripada 0 kepada 1 minit, kepada 60 second. So it wants the average rate of reaction at this area for the first minute. Alright, so the formula for this one is V1 minus V minus 0 over T1 minus 0. Alright, V1 is the volume of gas collected in the first minute, mana at the 60 second minus 0, and the time taken at 60 minute lah, at 60 second, at 60 second. Alright, so let's say this is a around 28. It's around 28. So how to calculate it? So V1 is around 28. Let's say it's 28 minus 0 over time is 60 second. 60 second minus 0. So 28 over 60. 28 over 60 is around 0.47 cm cube per second. So I repeat again, if the question asks what is average rate of reaction at the first minute it means 60 second. First minute means 60 second. Minit yang pertama maksudnya 60 second. So it want the rate of reaction start from 0 until 60 second, and the formula is a volume at the 60 second minus 0 over T1 minus 0. Alright, if the questions ask if the question asks calculate the average rate of reaction for the second minute, if the question asks calculate the average rate of reaction at the first 2 minutes. Okay, I repeat again. If the question asks calculate the rate of reaction at the first 2 minutes, maknanya first 2 minutes means from 0 until 120. Okay, 2 minutes equals to 120 seconds. At first 2 minutes from 0 to 120 seconds. So it's around here. So you want the average rate of reaction at this area. Alright. Let's say it's here is a 45. Alright. So the formula is as same as before. V2 minus 0 over T2 minus 0. So V1 volume at the second minute. Volume at second minute, we have 45. 45 minus 0 over T2. T2 at time at 2 minutes. 2 minutes is 120 second. 120 minus 0 is equals to 45 120, so 0.375. 0.375 cm cube per second. So I hope you understand. So the difference between just now question, just now is calculate the average rate of reactions. Just now question calculate the overall average rate of reactions, and now is the calculate the average rate of reaction at the first minute or first 2 minutes. Means the formula it must minus by 0. Okay, next we go for the next one. Alright, we go for the next one. If the question asks calculate the average rate of reactions at 2 minutes. Alright, I repeat again. If the question asks calculate the rate of reactions at 2 minutes, so means for example, if we have a graph here. Alright, so if we have a graph here, so if the question asks calculate the average rate of reaction at 2 minutes, means it want the minute 2, minute kedua 120 second, 120 second, 2 minute, at 2 minutes 120 second. Alright, at 2 minit maknanya dekat minit yang kedua sahaja. So kena tolak minit yang pertama. So dia nak just at rate of reaction at this area. Rate of reaction at this area. Alright. So let's say the volume here is 28 and volume here is around 45. Alright, I repeat again. The question, if the question asks calculate the average rate of reaction at 2 minutes, so means the formula should be V2 minus V1 over T2 minus T1. So it just want the rate of reaction at this area between 1 minute to 2 minutes. If the question asks calculate the average rate of reaction at 2 minutes, means it just want the rate of reaction between 1 minute to 2 minutes around this area only. So V2 is a 45 minus V1 is around 28 over T2 is 120 minus 60. So here what we got, 45 minus 28, we got 17 over 60. 17 over 60, we got 0.28. 0.28 cm cube per second. Alright, so I hope you all can differentiate the average rate of reactions. We have 3 example here, we have 3 conditions here. First, how to calculate the average, how to calculate the overall average rate of reactions, and the second one, how to calculate the average rate of reaction at the first minute, first 2 minutes, first 3 minutes, or And the last one, calculate the average rate of reaction at 2 minutes, at 3 minutes, at 4 minutes, and so on. So the difference, I hope you all can differentiate the question lah. Alright, next we will go for the last one. How to calculate the instantaneous rate of reaction. So instantaneous rate of reaction is the rate of reaction at a given time. Instantaneous rate of reaction is the rate of reactions at given time. Okay, for example, if we have a graph here, right? Right. Okay, instantaneous rate of reaction. So how to calculate the instantaneous rate of reaction? For example, if the question asks how to calculate what is the instantaneous rate of reaction at minute 2, at 2 minute, yang minute yang kedua, okay, ataupun calculate the rate of reactions at 2 minutes. Okay, I repeat again. The question can ask, calculate the instantaneous rate of reaction at 2 minutes or calculate the rate of reaction at 2 minutes. So, maknanya minit yang kedua. 2 minit maksudnya 120 second. So, 120 second dekat sini lah. So, kita make a dot line here. And then I repeat again, for the instantaneous rate of reaction or rate of reaction at given time, we need to draw a tangent line. So we draw a tangent line here. So the point is at here. So we draw the tangent line. Right? We draw a tangent line. And I want you to make sure when draw a tangent line from the center point here, the tangent line from here to here, from here to here, it should have same length. If here is 3 cm, here also should be 3 cm from the center point, from the center point here. This one should same length as this one. Alright, so we draw a triangle. Alright, we draw a triangle. So this one we label as Y2. This one is Y1. So this one is X1. This one is X2. Alright. So for instantaneous rate of reaction, we need to find the gradient of this tangent line. So the formula is Y2 minus Y1 over X2 minus X1. So sorry, this one should be X2, this one should be X2, this one should be X1. Sorry, my mistake. So this one Y2, Y1, this one X2, X1. Alright. So let's say Y2 is here. Y2 here is maybe around 65, and Y1 here is around 35. X2, so X2 here 180, and X1 around 30. So just substitute in formula. Y2 just now 65, minus y1. Y1 here 35 over x2. X2 here 180, where the x1 is around 30. So 65 minus 35. 65 minus 35, 30 over 180 minus 30 is 150, so equals to 30 divided by 150, so it's a 0.2 cm cube per second. So that is how to calculate the instantaneous rate of reactions. So I think that's all for today. Thank you for your attentions, and if you have any question, you can direct PM me and ask question. Alright, so that's all. Thank you.